Well, good evening, folks. Thanks for having me, and thanks for coming this evening. Kyle has pretty much set the scene in terms of climate change. What I'm going to do is to focus on one of the impacts of climate change, which is sea level rise, and we're going to talk specifically about how that impacts Glace Bay. Now, one of the things I'm going to be doing, as Eleanor mentioned, is I'm going to be putting up an awful lot of photographs of Cape Breton. And so your job is to tell me where exactly these are taken. So your first question is, where is this particular shot taken? Well, this is Glace Bay. Dominion, here's Brian's Point, Bridgeport Cove, old number 26 collieries in here, Table Head. You're looking back, there's the Donkin Peninsula, the new Strata mine, and way off in the background is Scattery Island. So that pretty much sets the scene in terms of the study area that we're going to be talking about this evening. In terms of how we're going to do that, and where's this picture taken? Right, Dominion Beach all along here. So I'm going to divide the talk up into two different areas. First, we're going to talk about what causes sea level change. So Kyle made a few comments on it. I'm going to get into that in a bit more detail. And then once we've discussed that, then we're going to talk about, well, what are the impacts? So first of all, we'll talk about sea level change. Now, when I get into this, a lot of times people think of climate change as only man-made impacts. As Kyle alluded to, and as if you notice the title of the talk, I didn't say adapting to climate change, I said adapting to a changing climate. And part of that is to understand there's a lot of natural variability. And maybe the best way to think about that is that if you're walking along the beach here at Inverness, or maybe you happen to be walking along the beach on Dominion Beach, and you see those waves rolling up the beach and sweeping back, rolling and crashing up the beach, sweeping back in a natural rhythm. Well, think of that, and then think of this particular quote from a geologist at St. X. The pace of natural change is like a song. We need to understand the natural beats and rhythms of our planet before we can detect a skip in the beat created by man. So first of all, I want to give you a handle on that natural rhythm and beat of our planet. Now, this is a map done by the geologists at Bedford Institute. So this is one of those really neat maps that shows the topography. Light green is low level, brown is the higher level, and the blues show what the elevation of the ground surface is below sea level. So here we have the continental shelf and down into the deep ocean area here. And here's Glace Bay there. So this is what it looks like now. So you went back 22,000 years ago at the peak of the last glaciation, this is what it looked like. And there's Glace Bay. So the ice mass came across right over top of Cape Breton, all the way out to the continental shelf, up around past Sable Island, about 150 miles offshore. So if you were standing here in Glace Bay, you'd have about a 1.5 kilometer thick ice mass sitting above you. Now what happens when that occurs is there's an awful lot of weight of ice, and it starts to push down on the ground surface. And that creates some problems for us if we're trying to understand sea level change. So I'm just going to introduce two concepts here, isostatic and eustatic. So all isostatic means is it's the ground surface moving up and down. Eustatic means it's the water level in the sea moving up and down. So maybe the best way to think about it is that if you were filling up your bathtub and someone said, okay, well, what's the level of the water in the bathtub? So you took your measuring tape, you went to the side of the bathtub and you measured down, and you said, well, there's the water level. But then what would happen if the sides of the bathtub were moving up and down as well as the water was moving up and down? You'd have those two combinations that you had to take care of to understand what the final water level was going to be in your bathtub. Well, we have the same thing here. Just a few little pictures to try and exemplify that. So here's a cross-section of the planet's crust. So here's the crust. You like the skim on the outside edge of an orange. And here's the mantle. And so as the ice comes through, it starts to weight the land down and it pushes up a big bulge of land in front of it. As it gets out to its final extent, it's really pushed the land down to its final extent. And as the ice retreats, it comes this way and the land starts to rise up. So another way to think about it is if you were laying on your back on the floor and somebody came over and stepped on your chest would start to collapse and you could hardly tap. And then when they got off your chest, your chest would expand out. Well, that's what the ground surface is doing, the crust of our planet. So it's almost a way of our planet breathing. Now, right now, we're sort of in the area where this big forebulge has passed through us. So we're on the downward side here. And so what happens is that the ground has come up, it's going down, but as the ice is leaving, all that water that was in the ice is now going back into the ocean. So the ocean is coming up at the same time. And we also have another factor in here called a hinge line. It just means that most of the Atlantic province, the land is going down. But once you get to Labrador, the land's going up. So we're at a hinge line here along the edge of Labrador. So what does that mean for Cape Breton? So let's see if we can't put that in context. So, 9,000 years ago, the ice left Cape Breton roughly about 10,000 years ago. And as it was leaving, there was so much of the sea tied up in the ice that in Cape Breton the water level was down 120 meters below present sea level. So, that's what Cape Breton looked like 9,000 years ago. We were not an island. We were linked with the mainland, we were linked with Prince Edward Island, and almost linked with the Magdalen Islands. CBRM was a lot bigger back then than it is now. A lot more tax base. Give you an idea? What you can also see here is that there were no Bredor lakes. They were all just a small amount of little freshwater lakes. And if you look at Bedford Institute did a fair amount of mapping of the bottom of the seafloor in the Bredor lakes. So Badek is there. And if you stand in Badek and you know the island off Badek, and then if you just went past that, well, you'd see all sorts of channels in the bottom of the Bredor lakes showing where all the old stream channels were when water level was down this low. These blue areas will be the deep part of the lake, so those were where the freshwater lakes were. Just up there was a big one just off of Ben Brea. Well, 6,000 years ago, as the ice was retreating, the sea level was coming up, and it got up high enough so that it started to breach right at the mouth of the Big Bredor, and it started to flood back in. So that's when the Bredor lakes actually started to be created, to where the saline nature that they are now. And one of the interesting things then is that you can see here are these old lakes, and you can see a channel going out of the lakes. And right where that is, well, that's where this is. And where would that be? Well, this is the Great Bredor Channel. There's the Seal Island Bridge. So Kelly's Mountain is over here. Here's Boulderview Island. You're looking back towards the Bredor Lakes in the background. Now, it's sort of neat, because the world talks about climate change and sea level rise, but we here in Cape Breton, we can show them definite proof of what happens, and we've already experienced about 120 meters of sea level rise. So perhaps the next time you cross the Seal Island Bridge and you look back to the south towards Badek, now you'll begin to think, geez, 6,000 years ago, that wasn't there. It was just a channel running down, a river channel running down through the bottom here and way out to the sea off around where Ingonish is. And that's sort of neat. Cape Breton can actually show the rest of the world what sea level change and rise is all about. Another interesting way that we can show it is if you walked along the shore in New Waterford or Glace Bay, at low tide you can see all this bedrock being exposed along the shore. Well, as the sea level rose, it started eroding the cliffs, getting rid of all that glacial overburden that was left by the last ice age, and it's such high energy environment with all the waves that it strips all that stuff off and exposes the bedrock. Well, PIMCO a long time ago did some pretty detailed surveys. Here's New Waterford right about there. And they did a survey offshore to see what that geology was like. So what you can see here is that here's about 1 to 2 kilometers offshore. The surface of the bedrock has all been scoured clean. So all these lines are actually the rock itself. You can see how it's being folded around in what was called the Bridgeport anticline. But once you get off into the deeper